I'm going to go to a cross section in tropical on the west coast. This is a really nice outflow, and I haven't seen it yet, so I'm kind of looking forward to seeing it.
We're live and ready to go whenever you guys are.
Okay. I think I might have heard some voices.
Yes. Yes.
Yeah, I thought it was.
I'm out of practice. It's like I haven't been jogging or something.
New version?
These I want to use. This is
Have you turned your notification on? Wake up, right? Isaac tweeting class.
Am I gonna
I only have it set to
Yeah.
so you can see you. From 9 to 5.
Those are two big
Yeah, I'll get
Okay, let's get started. Welcome to our weather discussion. We have a couple of them left this term, I think today, and then the last one will be the 6th of May. So we're almost at the end. Let's start today with satellite movie, Pete, over
You want this morning or the
Untitled
whole
U.S.
week?
Huh?
Do you want this morning or the whole week? The week is loading, but it takes a bit.
I just want this morning. Yeah, thanks. So I think there's going to be enough to talk about. Okay, thanks.
Yep.
So here's our satellite movie for this morning in the last 6 or so hours. And to my eye, I must say, this looks like something you'd see in June, July, or August. This is really kind of awesome. Juxtaposed with a clear example of like a wintertime disturbance off the Atlantic Canada, another one that's brewing here over Wyoming and Colorado, and I can't quite see obliquely, there's something else off the coast. But this is really interesting. Broad ridginess implied by the direction of the winds, and to the south of the ridge crest, perhaps, is where you get this interesting convective bloom. I don't know about lightning data, so we can maybe search around for that. I haven't seen any here and haven't heard any thunder, but it sure has the MCS kind
There
of
is
look to
lightning
it.
data on the AOS website.
Let's, we'll go there eventually, but not right away.
Yep.
Thanks. And so what we're going to talk about, I think, in my part of the discussion is what's getting organized to the west here over the Intermountain West, what influence that's likely to have on our weather over the next 36, 48 hours or so, and maybe longer than that. And then we'll talk a little bit about this structure here and what's going on here. Maybe we'll look at a close-up at some point and put it in the context of the broad-scale flow. So that's the plan that I have for my part of the discussion. So that's going to be the feature of interest around which some of the discussion will focus. Can we do a little bit of a close-up on that, Pete? Let's go to one of the 5-minute data or something like that. Yeah.
You want the Wisconsin one?
No, I like the Midwest. Gives us a little bit bigger scale. Thanks.
Visible infrared.
The same one we just had, colored infrared, is it Mercatus enhances the same color? Yeah, look at this. So this is really awesome. You can see all manner of things in the cloud top temperatures only. Little waves coming across where these things are exploding, through the tropopause boundary. And there's wave structure. And as I said, this is, I guess it's late April, so it's not really so outrageous. But it is in a funny place. This far north, kind of underneath the ridge and so on, it just strikes me as more of a summery event. And you can even see the anticyclonic tendency of the outflow, cirrus, on the edge in this close-up, right? Look at that. That's awesome.
That thing going in northwestern Minnesota.
Yeah, that's another one, right. And it's in roughly the same synoptic spot.
Yeah.
It's, the crest of the ridge is right about here. And so these are in funny spots. I don't know if this one you can't really see maybe the outflow cirrus, but here you can. You can't miss it. It's going around anticyclonic.
But John, being in that, under that anticyclonically curved flow and the anticyclone, doesn't that make the environment favorable for these?
Definitely does. Yeah, and that was one of the things that was consistent with this being here. I said, yeah, with the anticyclonic flow, low absolute vorticity, low inertial stability, the air has an easy time getting excavated from these columns of deep ascent. That's about as much as I know about that, so I was hoping that we'd have some severe people who would say something more about it if they're found the reason to do so. Let's take a look at the radar close up too at the same time if we can be. And we're talking about the ridge being there and all that. You'll see that when we go to the 500 milliwatt map. You're just presuming that at this moment. But there's all manner of little circulations in here, especially this one on the western edge of the whole complex. Look at that circulation that's kind of going towards the Mississippi River. I don't think I'm imagining that. Sometimes you do, but that's pretty good. And we had a little break in our rain here in the last hour or so, which was a nice surprise walking back to the building, but that'll be filled in within the next hour, it looks like. And then maybe that's it, because this whole thing goes by, stay cloudy for a while perhaps, but it's not going to stay raining, I don't think, all day long. Now it looks like it's going to be over in the mid-afternoon. And there's the feature up in Minnesota that doesn't have, it has the same sort of poorly organized look as this one does, but none of the little circulation features, if that's what they are.
I think the one down in Iowa is just a lot more mature.
Yeah, that's
It's been
probably
going for a
what
lot
it is.
longer.
Yeah. So it's a nice douse of rain for us. I mean, it was really, I'd say, periods of heavy rain this morning and a long extended period of moderate rain, and probably another moderate rain period coming. So we can certainly use it. Michael and I were talking about that at our group meeting today. We were 20 inches below normal for the snowfall in Madison, which is 2 inches of liquid equivalent. And that came after a fall that was about 10 inches below, fall and summer. So, you know, anything we get now is working against about a 1 foot deficit in total precipitation for the year. That's not good. But anything you get is positive. But we got a ways to go before we're done. Okay,
Did you want to look at lightning at all?
yeah, that's a good time to do that. Let's see if we can find the lightning. I have no sense at all whether or not there's lightning with this. Except that, I guess I do, in the sense that, boy, there's some really strong updrafts.
The lightning data that we get, well, there's other stuff out on the internet, but our stuff is under observation maps, there's a Wisconsin and a national version, and they're only available on campus because of the restrictions on the data.
Oh, yeah, that's good lightning there. None of it in Dane County, but all of the back edge of that whole convective complex where you saw the overshooting tops implied by the brightness temperatures there on the satellite. This is where it's all lightning. I don't think there's any, there is some up in the Minnesota feature as well. This is more dense lightning. So maybe that's what we see this afternoon in our next round. We see a little bit more obviously convective precipitation in that.
So for those unfamiliar with the color scale on here, the
Oh, yeah.
white dots are within the past 10 minutes, then the yellow are the previous half hour, the green are the previous half hour to that, and the blue are the previous half hour to that. So it kind of gives the illusion that you get a lightning strike and then it fades away over time.
It's very clear. It's a well-constructed illusion, so you get a nice idea of where it's going. Yeah, so, and I'm always intrigued by the degree of variability of the density of lightning strikes too. You know, look at right in this little strip, right across the central part of that county in Iowa. Nearly continuous lightning for the last 15 minutes. And then places just barely to the north or just barely to the south, intermittent.
Pretty
So
sure
that's
these
kind of
are
cool.
exclusively cloud to ground too. I don't think it picks up.
Oh, was that right? It's one kind? Okay. But even so, the density differences are interesting. All right, so this is, we have something to look forward to this afternoon for maybe some convective rain. Michael's saying bring it on,
Yeah,
obviously.
it's gonna die. We're not gonna see any. It's gonna go south. Northern Illinois is gonna look forward to some lightning.
Maybe you're right, yeah, Galena is the place to be.
Yeah.
All right, let's take a look now at our upper level charts on the super peak.
Oh, surface, you want to do surface at all?
I hadn't planned on it.
Okay.
Yeah, do you want to look
I was
around?
sort of curious to see
Okay.
if we can see anything at the surface associated, and where the front is located right now.
So here's Iowa, thunderstorm, moderate rain, thunderstorm in Rockford. Moderate rain in Madison at the time this off was taken, 46 over 43. Oh, that's really miserable. Heavy rain just across the river from La Crosse, or maybe at La Crosse. I guess that is La Crosse, right?
And you see that broad area of confluence in the northern third of Illinois. I don't know, my station, 68 over 60, just where you're.
Oh, yeah, right.
You go north of that and get dew points.
Wow,
drop off.
yeah, that's a good point. Huge difference here. We were talking about this in class, I probably didn't think about this myself, you're right. 21-degree temperature difference between Rockford and, what is that, Champaign? Well, that's too far west. Lincoln. And 44 versus 60 dew points. So the dew points are uniformly 60 or higher to the south. That's Saturday for us. And this is at least this afternoon. And what a difference. And you're right, Michael, obviously the strong southerly winds characterize the flow to the south where the high dew points and high temperatures are. And then in the vicinity, the convective precipitation, and outside of it, the flow is more from the east and then occasionally from the north because you're in a thunderstorm or something. But easterly flow, so strong confluence right on that boundary. So that's a sharp boundary. And when it comes through, it'll be noticeable immediately, yeah. But it'll probably be overnight.
There's not much wind change across the mountain, though. That's interesting. I mean, there's a couple places where we get northerly wind, but for the most part, the wind is not shifting strongly across the mountain.
Yeah, that's characteristic of these kinds of things. This is about an 80-degree wind shift. You know, you got broad easterlies up to the north, and then kind of south-southeasterlies here. So maybe it's about 60 to 80 degrees wind shift direction. But the speeds are higher where the air is more poorly stratified. You're mixing it down. So you're in the 20 knot, 15 knot range uniformly in the warm, moist air. And it's a struggle maybe to move the air around anywhere except at the surface. Where it's been raining for a long time, you probably enhance the stability with evaporative cooling or something.
Here's just an interesting point. In southern Illinois, there's a station 77/65.
Yeah.
And then another one in Missouri, 77/66. But then if you look south of that, east of that, west of that, dew points aren't much higher than that.
Yeah, so is this observational bias, or is it agricultural induced or
That's
something like
what
that?
I'm wondering.
I don't know,
Yeah,
that's a good question. Seems early in the season for that to be an agricultural burst of water vapor, doesn't it? There's a station, is it Lone Rock, that has a bias in temperature, I think, here in our own state, that people kind of routinely decry. And then I think also Waterloo has a dew point bias. They're always a little bit higher than everybody else. Though that tends to be noticed in June and July when the corn's growing, so I don't know. This seems early for that to be honest.
It looks like the corridor of moisture is going on more through Oklahoma and western Missouri, Kansas. That's where you're getting all the 60 dew points that are surging up, I think.
Well, it got 63 at, I think that's maybe Lincoln, I can't remember, or Springfield.
But if you go back further east, I think you were looking further east in southern Illinois, they're not high there, so I think
it's
the
just those
moisture's
two.
surging up more through Missouri.
Right, there's more of a jet-like feature further to the west, but
Yeah,
I was
that's
just
right.
commenting on the fact that the dew points in southern Illinois are kind of some of the highest on the map.
Yeah, that's true. It's-
Yeah, there's some, yeah.
There's a couple that are odd. There's another one here near, was that north of Columbia, south of Columbia?
Right, there's
60, that's one of the 65. So there's a patch in here where dew points are in the mid-60s, which is somewhat isolated. Yeah, you're right. I wonder what that is.
We have dried as in Colorado and New Mexico, 80 overnight heat.
Yeah, and of course, they're fighting miserable wildfires in parts of Colorado or the whole West. And that seems really early in the season for that. That's not normal. And you were talking to Chris the other day where it snowed pretty good in February and March and then stopped, and then it's been windy. So the combination of no precip and wind drying out the stuff that was already dry to begin with has brought it back to its original tinder state, and it's in bad shape. 81 over 14 at Boulder and places like that is just incredible. I could never live there. I'd have eye drops in my eyes all day long.
I used to
every
say
day.
that.
Yeah.
But after you're there a few years, you start to like it.
Even the dryness?
Yeah, even the dryness, you start to like it after a few years, but it takes a while. The first couple of years, you're miserable.
Yeah. It's too dry for me. I need dew points at least 40 in the warm season. They gotta be at least that high. Okay. Any place else you wanna go around the
No,
country?
no,
That was
just
really the
focus
main
on
story. I should
Up in
have done that
north
myself.
central Minnesota, there's some snow, so if that's associated also.
Oh, yeah, there you go.
The lightning that is.
Oh, yeah. It's snowing in a couple of stations where that convective thing is passing by, so that's interesting. And it's the only snow anywhere. It's 32 over 32 with light rain here. I don't know how that's happening.
The moderate range, just, yeah, right there.
Yeah, there's that Grand Forks. Yeah. Yeah. Was I right, Benji? Whoa! We should mark the calendar.
Write it down.
I feel pretty good about that. All right, okay. All right, let's go to the super Pete's at 500 millibars, where there's some pretty interesting action to speak of, and then we'll give us a little bit of a diversion. So, we had a storm in the satellite, the broad satellite picture you can see was over maritime Canada. That's tied to this upper trough. And then here's the ridge, where, remember, we have our big convective feature right over this region. That looks like summertime to me. So, really interesting, and even the one in Minnesota is clearly to the south of the ridge axis. So this is the place with the lowest absolute vorticity, broadly speaking, at 500 millibars, and so that makes it easier for the convective updrafts to get themselves out of the column. That's interesting. But then there's this really intense upper trough over California, and that's where our cyclone for the weekend is organizing itself over Colorado, Wyoming. What I'm really interested in looking at next is this analyzed upper fronts. This is like 10 to 15 degrees by the time you get to the coast of California. It's 15 degrees across that thing. And I've seen them like this in April before, and they can be really intense structures, so I'd really like to look at that in a minute, upstream of this intense upper trough. So it's, again, a pretty wavy flow. We're at the end of April. I don't really know, I think, what the climatology is in April for that metric, but I think it starts to rise rather rapidly in the late winter, early spring for a period of time. And so a pretty wavy flow. Let's take, before we go to the cross-section, let's take a look at the jet structure at 300 first, and then we'll go to 200. So not surprisingly, a pretty intense jet on the western side of the upper trough off of California. That tends to dig the feature a little bit. I think that might be in the forecast to slow down the motion of this storm that's developing. It's going to take its time, bringing with it the precipitation along its cold front, actually, till Sunday. And until it does do that, we'll have strong warm advection from the places to our south with temperatures and dew points that are astronomical compared to what we've seen the last month. And here's the other upper trough off the east coast with a strong jet flow, and it's in the northwesterly flow to the east of the Great Lakes. And then a more zonal flow well out over the eastern part of the Pacific Ocean, south of this cutoff that's sitting south of the Aleutian chain. We'll take a look at the satellite for the west coast before we do the cross-section. Let's see what, no evidence at all of a subtropical sort of jet at 300 millibars. Let's see if that changes when we go to 200. Here's a bit of a subtropical jet over the Caribbean and east of that. And one gets the impression that the flow over northern Mexico is part of a separate wind speed maxima, not the one that was associated with the strong northwesterly flow. In fact, that disappears to some extent at 200 millibars. So that's a stronger underlying jet than it is at 300 millibars. The feature out over the Pacific looks roughly in the same orientation and in the same sort of magnitude. So that's probably a fairly deep jet structure. And the same vanishing wind speed max at 200 millibars applies to the feature over the Great Lakes. So that's a polar jet that's receding in magnitude the higher up you go. So this is one of those days where the subtropical jet doesn't have a really strong presence over southern North America. And that occasionally occurs. And so everything that is going on in the wavy flow in the mid-troposphere has perhaps been generated by or moved southward from higher latitude and polar origins, which maybe is the reason why it's going to be cold for the next 10 days after Saturday. Okay, can we go to the West Coast satellite movie, Pete? And then we'll come back to tropical and look at that upper front. So remember, we had a pretty decent cutoff cyclone over the Aleutian chain at 500 millibars with a strong jet, both at 200 and 300 millibars to its south. And that's really clear in the satellite picture. Here's the center of circulation of the lower tropospheric, probably middle tropospheric circulation center, but there's a cyclone at the surface down in that region as well. Very nice structure. But look at how the wind speeds are just being carried straight along, the cloud elements are being carried straight along zonally here at about the latitude and longitude of that upper low, and that's, I think, because of that strong jet. There's no waviness in that flow in the middle with a high upper troposphere, so it's just carrying these things zonally across to the west coast. And here's the manifestation of our strong upper trough off the California coast, so oriented about like that. Downstream of it, clouds are developing in the ascending air over Utah, Nevada, Idaho, parts of the Intermountain West. Not well organized yet, but widespread. And I'm not sure, this might be a little baroclinic leaf cloud developing at the front edge or the eastern side of another upper trough, which is at a very low latitude. It's like 30 degrees north. Where that came from might be of interest. But that's a nice little storm that's developing on the far western side of that strong zonal jet. And a convectionless tropics in this portion of the subtropics today. There's Hawaii, just for reference.
To point out that in this circulation globally, it appears, when I look at these jet stream maps, that the northern hemisphere branch of the Hadley cell seems to completely shut down.
Oh, yeah?
I mean, the subtropical jets across the globe are almost disappearing entirely.
That's interesting.
And there's a polar night jet forming on the Antarctica side, and the jets are very strong in the southern hemisphere. So the Hadley cell circulation is usually biased toward the winter hemisphere, and it seems to be completing the flip this week toward the southern hemisphere.
And it's about the time when polar vortex disappears too in a normal year, right, mid to
It's
late
gone,
April.
it's been gone for a month.
Yeah,
The
it's,
polar vortex.
it's a weird year this year, but even in a regular year, this is about the time that goes away.
Yeah.
But this is so I was right about my impression here, this is really a convectionless subtropics in this part of the
Yeah,
Pacific
it's
Basin.
just dying right
Right,
now.
so Greg and John, is that consistent with this, the continuation of the La Nina pattern in the equatorial
Oh,
Pacific?
I don't know, I guess so. I mean, a La Nina would make it cold right about here into the coast, right? Yeah, so that might be another factor, yeah. And if you're not pumping equatorial planetary angular momentum upward and then to the pole, you don't have a subtropical jet, and we didn't see one at all over the North
I
American.
don't think
base.
that's because it's global, it's in all hemispheres. The northern branch that had these hells gone.
Okay,
It's not just there.
okay, yeah, but when it is gone here, there's no subtropical jetting.
You look at these
coming into North
retracting
America.
jets across the Pacific, there's nothing there right now. It's almost as jetless as you ever see it.
Wow, that's weird. I wonder what the climate was for that. What's the minimum subtropical jet point in the year in the northern hemisphere? I wonder when that is.
I don't know. I think in the summertime, it pretty much disappears.
No, it comes up to high latitude.
Well, if you want to call that.
I think you have to call it that, like we talked about
I guess
before.
you're right.
You
If you want
instigated
to-
that idea. I think you're exactly right about that. I think that's why, I think the polar jet disappears. I think subtropical jet just encroaches on high latitudes. But maybe that's not
Well,
right.
it doesn't have the same high tropopause. It is a jet driven by more of the convective features, but it doesn't have as high a tropopause as the subtropical jet that's born in the tropics.
That's an interesting question. That can be interrogated, so we might have to do that.
Yeah, I do.
Yeah. Okay, now, can we go to tropical, Pete? Tropical tidbits? Because I think that's where I draw the cross-section that I'd like to look at. Thanks. We'll have to be off the west coast. This probably won't do, unfortunately. It'll give us too much of a truncated one. Rats. See, these tropical guys, they don't. North Pacific, maybe? I don't know if that'll do it.
Southwest US.
It does seem to give us a little bit more. It does seem to give us a little more. Let's see what that looks like, yeah. Maybe that'll be good enough. Can we go to 500 millibars? Do we have a 500 millibar temperature option here to get an idea? Maybe in thermodynamics? 700 temperature might help. Yeah, okay, I think this will be okay. Let's try and draw a cross-section like right through there.
I don't use tropical, so how does, is it
Oh,
control or?
I think it's control.
Control flood.
Yeah, there you go. See what that looks like. And then let's do the PV first. That'll give us theta. Ooh, yeah, that's not bad for going blind. And so this is the cold air, so somehow they kind of switched it on us. But there's the jet maximum 120 meters per second, I think it is, right? Must be knots. And there's, look at this upper front. I mean, this thing is really quite remarkable. Sticking all the way down, the 2 PVU line is the dashed line, comes all the way down to 750 millibars. So that's a really strong upper front that's associated with this upper trough to our west, which is spawning the cyclone that will influence our weather over the next couple of days. So that's really nice. Sort of a dual jet structure. One of them's at about 250 on the 330 Kelvin line. So there's no subtropical jet in this cross-section. This is all polar jet by the wintertime standards. We don't know what they're like when they switch from March, April, and into May. We have to do that work. We're in it right now. Taylor Norton's leading that charge. So that probably is a polar jet. I think that's for sure. And this is clearly a polar jet type appendage of the upper front. Be nice if we had ozone mixing ratio. I bet it's really low, or high ozone all the way down into the middle troposphere in these locations, which is kind of interesting.
So John, when you showed the 500 millibar map from the super peaks,
Yeah.
it seemed like this front has pretty much done its job in terms of folding this far down, because it looked like there was more warm advection occurring along the axis of it.
Yeah, I wonder if that's because the analysis of both the geopotential height and the isotherms, they might be just off a little bit, although it might actually be exactly the case as it is right now, I don't know. So if it was real observations that we had the analysis on, I feel a little more confident. But there's the 500 millibar level, and there is a strong temperature contrast. You're exactly right to wonder what's the thermal advection pattern at this level, because that would tell us, at least to a first order, what we might expect for subsidence or ascent. Maybe we can look at vertical motion. One of the problems with tropical tidbits is they change the scale on all the cross sections. Maybe we'll get lucky.
Omega.
Yeah, omega's the third, there we go. So if it's 100 millibars, it's not, it's 300, but, so let's go to 500 manually. And these, I think the solid pink, that's frontogenesis. Where's the vertical motion? Shaded?
Basically, yeah, the shaded.
And the gray is sinking, right, I think? Yeah, so there is subsidence through here, and but there's horizontal frontogenesis. That's interesting, going on there. At 450 millibars, not quite at 500. So kind of hard to know what that all means.
Actually, that gray is ascent, right?
Is it?
The blue is sinking, the negative is omega. That's that line.
Yeah, so the gray is positive omega, that's substance.
Great.
I can't tell what's blue and gray.
Substance, right.
That's blue and that's gray,
Yep.
but I can't tell maybe right now. So, it's weak, but it's consistent along the theta gradient, so that's nice. That's gonna be upper front inducing. And the green lines are theta E this time, but they don't really look different than theta, at least in this part of the troposphere. So that's a pretty strong upper feature. So that's what I wanted to look at. I wish I'd had more time to think about looking at an evolution of these features, because that would have answered some of these questions, but the schedule doesn't allow.
On the left side there, that's the lower frontal inversion. That's actually the marine boundary layer, I think, the top of the,
Oh, this right here, at 750?
yeah, it's about 750 up to 550 or so. That was packing of isotropes there.
Mhm.
It looks like a it looks like a frontal zone, right, in the
Yeah,
cross
yeah.
section. But it connects with this other one. So this front kind of merges into the marine boundary layer.
Yeah, is that usually that high?
No. Further south, it is, not there.
Okay.
How far south are we there?
We're down to, I don't know, is that maybe 20, 30 degrees? Veracruz
Yeah,
latitude?
that's getting there where, the marine boundary layer gets deeper and deeper as you go
Okay,
further south.
okay. Yeah, that's a good point. It does look like it might be juxtaposed. And then can we go back to the PV, Pete? Because then you've also got this, it'd be interesting to say, here's that same, this is now dry theta, and it goes down to 900 where that stable layer starts.
Yeah,
So that's the marine boundary layer, but you have some stratospheric air making its way onto isotropes that are part of the sandwich of the marine boundary layer. That's pretty interesting, yeah. It's really interesting.
Often you'll see it connect with like a surface inversion, even an nocturnal inversion over the continent during the winter.
Yeah, in the wintertime especially true, yeah, that's right.
So it's connecting now with the marine feature.
Yeah, and that is elevated PV in this stratification. You can see it it doesn't get to these values, but it's higher than the light blue, which is the background, like 0 or minus 0.2 or something.
So could repeated folds during the winter and fall and winter help maintain the stability at the top of that marine boundary layer?
I don't know.
Is there any relationship between that
Between
marine
the-
boundary layer and these upper fronts that come down the west coast?
I've never noticed it, but there's a relationship, and the marine boundary layer interacts a lot with Catalina and things like this. It certainly has some effects with topography and other things. I never really looked into it. I don't know. I don't know much.
That is an interesting idea.
Well, I know it does slope upward and gets deeper as
Yeah,
it
yeah.
goes up.
That's really interesting. I wonder if that isn't true. And you could have interannual variability in passage of upper fronts here and depth of the marine boundary layer in April.
Right.
How does it respond? That's really interesting. So, that's all I have.
Okay. Thanks, John.
Yeah, thank you.
We're gonna go to. I think
Thanks,
all
Pete,
the-
for driving around.
Yeah, I think all the tabs got closed up when I restarted Firefox. We'll go to Sol, the AOS, WSW, please. And current run. Actually, could you also bring up, oh, there it is. Right here. Go to first. Actually, NWS hazards. So just starting with the hazards map for the current National Weather Service hazards. Flooding concern in eastern Iowa. I think really interesting is this, we saw this middle of last week, early last week, where they had the blizzard in North Dakota. They had blizzard warnings believe these are blizzard warnings that are now up for parts of the Dakotas as well as eastern Montana and northeast Wyoming, winter storm warnings and winter weather advisories all the way down to central Colorado. So the storm that's about to get developed is going to dump another swath of snow across Colorado into the northern plains, and so they're going to get some more precip and some more winds with those conditions. These are so-called red flag warnings, the really dry areas out over the western part of the United States with strong winds, the possibility of some fires.
What's in New Mexico has been burned
Yeah,
recently?
they've had some fires in New Mexico, and then some freeze warnings in, I guess, just north of, I guess, the vineyard country of parts of California as well, so cold wine.
It's a cannabis country too, I guess, is what they say.
Right. It's
Humboldt County.
Great, well, yeah, that's another area. So that's some of the conditions there. If you look at the Climate Prediction Center outlooks, also on this page, just looking for the next 6 to 10 days. Yeah, we're getting some warmth. We'll see that in a little bit, but it's not going to be long-lived. Much of the eastern part of the United States below normal, and southwest just continues to sort of bake above normal temperatures. So we go ahead 8 to 14 days. If you're looking for a big warm-up, sustained warm-up, it's not evident certainly in the next couple weeks. In terms of precip,
Do you think this hot weather and dry in the southwest,
yeah.
do you think that might cause our cold weather in the sense that it creates a circulation that falls in the air over us? I wonder.
It's hard if it's which one leads the other, because I think you have the broad ridge that's there, and it's kind of everything, hot air beneath that ridge. It helps with the northwesterly flow, but having the ridge there is what's giving the northwesterly flow and the warmth. So it's hard to see which one leads the other.
But once one of them's in place, this doesn't hurt.
Right,
To
yeah.
keep it
It
there.
all
This
gets
works
over.
towards stationarity for
Yeah.
sure,
Sustained.
you'd think.
We'll start appreciating the coolness after a while.
I know, yeah, that's right.
But the weird thing is, with this same pattern, likelihood of above normal precipitation across the northern plains into the central Midwest, not quite over us. That looks a little bit odd. And
So
then-
that's little ripples in the northwesterly flow, as the Arctic drains of TPDs or something, they're gonna die if they don't get out of there. And-
But how much water vapor do you think you can carry from the Pacific?
Well, that's a good point.
Over us, so,
That's a good
but again,
point.
it's above normal. What normal is, could be just a little bit of light precip.
Yeah, and it's precip probability only, it's not
Right,
how
not
much.
the amount, right, so the darker blue we saw there doesn't mean necessarily it's gonna be much colder, just means greater likelihood of being colder. And then the summer outlook, unfortunately, that tab is gone, but the summer for the entire continental United States was likely above normal. So it's gonna be, we'll look at that next time.
Happy Earth Day.
So, yeah, Earth Day today. So let's go to, current forecast, and we'll go down to the meteorograms. Always gotta pronounce that.
Yes, awesome.
And also, Pete, could you go to the terminal for a second first before we get to that, just to see the weather here? Yeah, so here are the ops from Madison over the last
Look at that.
12 hours. And you can see that period of heavy rain that John was mentioning earlier. We had some moderate light rain earlier in the morning around 12Z. Then we got to heavy rain. Temperatures just around 6 degrees Celsius. As we scroll down a little bit further, we can see that current ob is 8 degrees, dew point of 6, and we had that east-southeast wind at 50 knots, gust to 20, so just moderate rain in the last hour at the airport. And it looks like we've had 3,600s plus 3,100s, so we're at 6,700s
Yeah.
of inches of liquid precipitation over the last, since 12Z, so it's been pretty wet out there, so it's been a wet act. And we'll look at this and compare this with the actual short-term forecast, see how that's verified.
The one good thing about this cool weather is it's been persistent, and none of the trees are blossoming out.
Yeah, that's true, yeah.
Right.
They haven't been fooled.
We're not gonna get a lot of,
Lot of-
destruction of the foliage from getting cold and getting warm.
Yeah.
Right.
Is Saturday gonna mess with that if we get up near 80?
It'll mess with it, but it depends on how cold it gets after that, but, yeah, it'll mess with it. The trees are ready now, you can see
Yeah.
some actual flowers in there. They haven't come out, and they normally come out now. The last week in April is when they usually start coming out, they're not that close yet.
I wonder what the latest date that is, hopefully,
Oh.
does.
Oh, yeah,
Yeah.
yeah. I don't know.
someone in the ag school might know that. If they're listening, please let us know. Let's, but we'll leave that for a moment.
Oh.
And go into the,
More STEM, huh?
right, STEM. I think you're barking up the wrong tree, Jim. Anyway, temperatures increasing over the next, we don't even have really a obvious diurnal cycle or any diurnal cycle that shows that the temperatures are dew point. And the rainfall is just off the charts, so to speak. We already at 0.63 at 18Z, so the forecast of total accumulated precipitation is this model a little bit behind in the precip, but it actually did a pretty good job of getting that initial burst. We'll see how that evolves in the forecast. Let's go to the time height section, please, Pete. And in that, we'll see no evidence really of a dynamical tropopause. It's really high up. That's consistent with the jet being well to our north. And the vorticity gradient associated with that jet being well to the north. It's only later in the period when we see an upper trough beginning to approach over us. But the model did a pretty good job, very decent job of depicting this really strong pattern of ascent, some of the strongest numbers we see on this map at any given time. And the really strong stable layering of the surface, which is associated with a surface baroclinic zone that we'll take a quick look at as well. But the most interesting thing, or the thing that's going to be great for us, is this period as the relative humidities drop off. Still even ascent that's occurring through tomorrow morning. But we will have a period tomorrow before we see that weather system to the west beginning to approach on us, where we're going to get some significant mixing. It'll be quite breezy, and we're going to have temperatures approaching, this is what, 300 Kelvin here, so we're looking at temperatures, possibly getting to the upper 70s to low 80s during the day tomorrow. And it looks like relatively clear skies might be a little bit obscured by some higher cloudiness beginning to move in. But we have a period in which we'll warm up. And then unfortunately, we're going to lose 10 or 15 degrees worth of temperature by the time we get to Sunday, as we get ascent, clouds coming over, and maybe a little bit of precip. So we'll see what this looks like when we look at the surface maps in just a moment. Okay, next, let's look at the short-term forecast on the Madison area maps for 6 hours into the forecast. So this is zoomed in, and even more zoomed in as Pete just did that, but you can see the total cumulative precipitation during this period. And this is just in the last 3 hours. This is a 3-hour cumulative precipitation for Madison was about, a quarter of an inch or so, which is pretty close to what was forecast. We saw at 18Z, or in the last hour rather, that we were at close to 8 degrees Celsius with the east-southeast wind, so the wind direction and all that really works out well. But that huge area of precipitation that we saw on the radar, that was over eastern Iowa and moving eastward, we can just see the depiction of this isn't showing the instantaneous precipitation, it's the cumulative precipitation, but you can see the effect it's having certainly north of this boundary, where the isotherms are. There's the isotherms in red, just keeping things relatively cool here, but with a strong southerly wind. If we go ahead just 3 hours on this map, to 21Z, so 4 p.m. Okay, that heavy precip is, heavy amounts of precipitation are forecast to have accumulated over us. And you can see again this strong southerly wind and the baroclinicity beginning to tighten up. So we actually have sort of active frontogenesis occurring right over us. But I don't think it's necessarily due to, it's not really the area of accumulated precipitation isn't along these isotropes. I think it's really this convective complex that's moving over the stable layer, helping to create that precipitation, but it is actively frontogenetic.
You almost get a sense, though, right to the west of Chicago, O'Hare, there's an elongation of the lowest contour, the purple and the light
right
blue.
here.
Yeah, that does start to look a little more parallel to the.
So that could actually be
That might be the beginning of that, yeah.
Let's go ahead 3 more hours, please, Pete. So again, a wet afternoon coming up and staying cool. Look at how intense this baroclinic zone just shows up. And the winds, again, across it, and again, this is where I guess you can really see that frontal type feature right here. But really, you have almost, 150-degree wind shift perhaps across that boundary. Temperatures to the south, this is 24 degrees Celsius, which is 75 or so. And then on the northern side of this, you're barely getting out of the 50s. So really intense baroclinic zone. But the warm advection is perhaps going to win out as this convective complex continues to move eastward. Let's go ahead another 3 hours, please, Pete. Slow, still warming up to the south. Really intense baroclinic zone. So a couple of interesting things. How rapidly will this lift northward? Will we see those temperatures really just continue to increase overnight as the model forecast is, and we'll look at Moss in just a moment. But when you have this active front, I mean, look at this, this is still 90 degrees or more wind shift. You're gonna expect to see in the lower levels an adiastrophic wind that's directed from the cold to the warm, which is perhaps gonna slow the progression of this boundary northward. So I think I mean, it's not a big forecasting concern, I think, for most people, but, you know, just when we'll let warm air break into our area is gonna be something that might be a little bit of a challenge in the forecast.
What's the time of this one?
This is for 15G, so this is 10 p.m. So there are gonna be places to our south tonight, southern Iowa or central Illinois, that are probably gonna be in the, at 10 o'clock, they're still gonna be in the 60s.
I just noticed the NMS from last night was just forecasting very heavy precip for this afternoon.
Right.
And it's all convective, and it forecasted a bunch for last night too,
Mhm.
which we had. And I had an inch in my game. This
Right.
morning.
This is, I mean, this is in this contour right here, this is just in 3 hours. That's between 1 to 1.5, yeah.
It's the kind of thing, but it's right over us.
If you go back,
This afternoon, yeah, I mean, you had it, I think.
Let's go to 9 hours, maybe.
Yeah, that's right, on
Yeah.
top of Dane County.
That's about an inch, approaching an inch,
Yeah,
in that 3-hour period. So this is a really wet forecast. So again, it was off the charts on the meteorograph.
So one of those questions I have, related to when you're pointing out, on the next time when we have that really strong baroclinic zone in the lower troposphere and strong frontogenesis along, what's the stratification of the air upstream like? I mean, what kind of air are you pushing over that boundary or
Right.
putting into that vertical motion factory? That's one question. The second one related is, how deep is that baroclinicity? If it only goes to like 900 millibars, maybe that doesn't have quite the same punch as it would if it were deeper. You know, if you have a
Right.
cross section, we can tell.
Yeah, so let's go to the time height, that's probably just.
Okay, yeah.
But let's see when the baroclinic
You
zone's right
keep
on top
track
of
in there
us.
of how much of that is convective versus how much is statical?
Yeah, but it's not, we don't output it, and I have to go back and look at the GenBack files for it, GenBack files for it. But again, this is a pretty deep layer of stratified air.
Yeah.
It's heavily stratified here, and then the weaker stratification is really in the mid-troposphere. And when that baroclinic zone kind of flips, all right, we go from easterlies to southerlies, it's still.
Yeah,
it's still pretty
you know, just
stable.
thinking about the backing of the winds with height and all that, I think I'd probably put it at the 300-degree Kelvin isentrope, probably the top boundary of the cold front.
Right here, yeah, okay.
And that's pretty deep. So that, I think that's going to be the question, is what's the air like in central Illinois in a sounding that comes up over this boundary overnight?
Is that in terms of precipitation and convection?
Yeah, exactly. If it's, you know, convectively unstable with very little inhibition, you're going to have some explosive event coming over us. If it's more strongly capped or something, maybe
Right.
that makes a difference.
So
That's the impression I get, it's gonna be pretty explosive.
Yeah.
But I think it's gonna wipe out that front, you don't think?
Oh, I don't know. I mean, that front's kind of reinforced by the
Right.
cooling that's going on where it's already rained.
And
so-
we can look at we'll look at some other models to kind of verify this. Sorry to interrupt.
No,
Okay, so let's go back to the forecast, we'll jump ahead to,
It's all elevated.
let's go to 24 hours.
Yeah.
Interesting.
So by tomorrow morning, that baroclinic zone is sort of burst through to the north, and this isotherm is 18 degrees Celsius, so we're looking at mid-60s early in the day tomorrow. And the warm advection just continues. Let's go ahead.
Is that just a weird contour interval, or is it that,
It's every 2.
but, sorry,
Southwest of
south
it
of
is like
Wisconsin,
no green
is
at
that
all.
just that equally?
Oh, in terms of,
Yeah.
well, no, there should be more contours here, but it's just uniformly
Oh.
warm there. There's no constraint placed on it.
That's a good question. I thought it was like Land's End or something.
So let's go ahead to 18
That is
and see
a
tomorrow.
wide region of plus 16 to plus 18.
And here's 24. But yeah, this is, again, the precip's over. You can see the lake shows up really nicely here, but pretty brisk winds out of the south tomorrow. And it looks like a fairly dry day. Again, the question is how warm we're going to get. We can do a couple things. First of all, let's go back to the terminal. You scroll up, or we can go to the Moss numbers. Again, here, first set at the top. This is for the GFS. Again, it also keeps our winds out of the east-southeast until about midnight or so, then they flip to southerly. There's not a really big rapid increase in dew point until you get to around 12 in the morning. And then temperatures begin to rise, but it's also because precip's over, and we're also getting sun coming up. But
And our first
GFS
80.
is going 80 degrees for a high, 53 for the low tonight, and again, the temperatures are just, well, it's 53 early in the period, it basically just slowly rises all the way up. The NAM, on the other hand, just within a couple degrees of that, 51 over 78, and a very similar pattern with winds east-southeast until around midnight or early tomorrow morning. And then they turn more to the south and southeast, south-southeast, and those dew points and temperatures jump up 78 and 51 for the low. So that's going to be interesting. Again, very little chance of precipitation, but notice they keep broken for the sky conditions over the weekend, so that's going to be one element that keeps things just a little bit down temperature. So let's go back to the NM5, and we can just step through at the surface. We'll just start off with the current map. It shows that huge area of precipitation. Again, this is a 6-hour cumulative precipitation. You can see sort of very broadly where that warm front might be, but it doesn't really capture the intense gradients of the surface. And this is really in terms of this is thickness that's shown here in the key area. Go ahead, 6 more hours for this evening. The convection complex moves east. And I know folks were saying maybe it'll go across northern Illinois as opposed to get to our latitude, and that's got another feature that could keep the baroclinity much further to the south. This seems to lift it across the Wisconsin-Illinois border. Strong convection to the south, and the cyclone's beginning to rev up nicely, and to the northwest of it, this is the area where they're expecting the blizzard conditions to set up tonight and tomorrow. Go ahead, another 6 hours, please, Pete. The 0Z tomorrow, so 7 p.m. tomorrow. Oh, sorry, this is 18Z tomorrow, 1 o'clock in the afternoon. Again, really nice cyclone, nice area, broad area of precipitation, and along this developed cold front, we can see convection beginning, or precipitation beginning to develop, likely convection. That could get interesting, I guess, for south. SBC, I think, has, they're looking for convection to occur here, maybe there's a slight risk of severe to the south with that, along that cold front. One more quick ahead, please, Pete, for tomorrow evening.
Look at that, that's a beautiful looking storm.
And that's a nice, this is definitely a nice looking storm with, again, a nice band of precipitation along the cold front, heavy precipitation and strong winds to the northwest and southwest of the surface cyclone. This marks the end to our warmth by tomorrow evening after this time period. This is actually 1 o'clock in the morning on Sunday. After that, temperatures are going to begin to fall with a brisk shift in the winds as we go into Sunday morning.
That looks like an idealized simulation.
Great.
Christoph Scherer, the ones you have in your model, right? It's just exactly like it.
So that's a really nice looking cyclone.
Yeah.
And we'll go ahead just to the end of this run at 60 hours.
You don't see any severe storms on this front coming through?
For us? Yeah, I don't know. I don't think, at least in the SPC outlook, that we could check that. That wasn't being looked at, but I haven't looked carefully at this particular forecast. This is now Sunday evening. It looks like it's going to be a slow passage for this front, so it's going to be probably cloudy and not very pleasant on Sunday with rainfall most of the day as this struggles to clear our area. And then I imagine a lot of this is snow and rain showers in the wake of this cyclone. Beyond. So let's quickly look at, I don't know what's the time, look at go to pivotal, and we'll go to the GFS forecast. We'll get to this. This is snow next week, but no one can see that. And let's go to 12 hours of the forecast, and maybe zoom in a little bit to get a sense of how it's handling regional. Before we get to this, let's go to temperatures and winds. So that really strong baroclinic zone that we saw on the in the MM5 is also shows up pretty well here. If you just saw before that, we had that little bit of precipitation, convective precipitation. Again, it's a much higher resolution model run. But look at that.
The red
obvious
menace.
wind shift. I mean, this is bloody warm, I guess, to
Yeah.
the south. Right. and a nice wind shift along this, but that's the front. And kind of uniform temperature-wise. which is
Yeah,
not bad.
it's
So-
incredible. Look at how
You
large
can
that
see more
area is.
detail on the actual screen, like
Yeah.
some, it's still very uniformly red,
That's
but there's
amazing.
some elements of projection.
Yeah. And also, this is 0 to Z, so 7 PM. These colors in here are in the 80s. Actually, we could move this around, right? Look at
Wow,
that. So
look
it's
at
gonna be really warm. In South Dakota, and then just one state to the north and part of the
Blizzard.
west, our blizzard conditions beginning to develop. That's gonna be really interesting. But we can do a sounding, at this time. Let's do one over Madison and go.
And then let's do one
further
south of it, yeah, see what that area looks like now then.
A really strong cap here, really strong stable layer. We saw that evidence of that. I think you're right, John. It only goes up to about 800, 900
Yeah.
millibars or so. Above that, we're in the.
That's a pretty good sounding above that. If you can make that rise, you're in good,
If they
you're
can
in
break
business.
through this or lift air over that and then let it
Yeah.
go above the top of it. And if you go to the south, maybe over Springfield or.
Yeah, and then this is the end that's gonna be lifted over it, so let's see what that looks like. No, yeah, look at that. That's like uniform theta E all the way to 875 or whatever that line is, and it's all positive area. A lot of it.
So it's not huge, right, for surface parcel.
Yeah, but imagine you'll be lifting that whole stratification.
Right, okay.
You know, over that boundary. So that's probably gonna be pretty good.
I'm wondering what the outlook is for convection then. 'Cause I haven't seen anything.
Yeah.
It's pretty serious. We haven't had a front south of the triple point like this before this year yet, coming in.
I think that's right, yeah.
Let's take a
Oh,
look.
this will be pretty interesting.
Day-
Hmm.
It's the non-zero effect. This is day 2, let's go to day 1, which I think is concerted later on this afternoon.
Hmm.
Marginal risk, I guess,
Yeah,
we're just on the edge.
we're on the edge of that. That's a bit surprising, but they know their business better than I do, of course.
And those that are taking 453 are looking, but yeah, so we'll say a hailer is. Okay.
All right.
Thanks. And we'll just go back to the, quick out of this, go to the surface map and just kind of, before we get out of that, let's go ahead to tomorrow at 33 hours in the forecast. So 21 feet tomorrow.
Whoa, Red Menace has made its way all
Right.
everywhere.
And so this is just the output from the model directly. It's 2 meter temperature, 74, so we saw the models went up to 80. So this is gonna be, got a nice warm day, lake still staying chilly.
Cold
there,
day at
but-
the beach.
Cold day at the beach, you're gonna get in the water there. And this cooling here is presumably where we have precip occurring. So if we go down to the precip rate type,
Yep.
you can see clearly where that shows up nicely. Imagine 20 years ago, looking at a
I
forecast,
know.
you didn't see any of this
I know,
structure
it's
at all in
amazing.
the forecast.
It's just amazing.
We're getting old. Okay, and then the passage of the front, we're looking at that sometime, at least approaching us by Sunday morning. Let's see how the model's time at 48 hours. So there's the slow patch. The front's still back here, right? A lot of precipitation ahead of it, and maybe some showers behind it. Then those rain showers and snow showers back over the Dakotas. And 60 hours in the forecast. Oh, it's got a nice front.
It's gonna feel like Duluth, one day of summer and then we're back.
Okay. And we just go ahead to 72 hours for the temperatures.
Yeah, that's
Yeah.
a whole different story.
Chilly again. 43 on Monday morning. Not a pleasant time.
Well, at least it comes on the weekend.
Yeah. So, that's really, I'm gonna wrap things up at this point. The key things are a lot of rain continuing throughout the afternoon and early evening, possibility for some convective precipitation, and maybe even a slight, just marginal risk of severe weather, maybe hail, I guess is what the SPC is looking at. And then later this evening, early tomorrow morning, that warm front finally makes it north of us, and we break out into sort of a warm, humid feeling type of early morning tomorrow, and then tomorrow will be just warm, breezy, mid-70s to near 80 degrees, and showers approaching tomorrow evening. So nice day tomorrow to be out and doing stuff. Chilly and showery during the day on Sunday. That's,
Just a quick little tidbit,
Yeah.
in regards to the moisture associated with the severe weather threat today. The previous record for the Omaha sounding of observed dew point was like 62 degrees. Right now, the dew point was 68 in Omaha, so highly anomalous moisture return all the way up here at this time of year.
is this for this date for
Yes,
Omaha?
for this day.
68 is considered a record.
Considered high, yeah.
Do they list the mixing ratio in those records?
Let's see, I've got the climatology up here. Yes. Let's see.
15.
Today's record mixing ratio was 12 grams per kilo.
So 16 is more, 68 is more like 15, probably, right?
Yeah, that's what I'm thinking, yeah. Maybe a little less, maybe a little less.
So this is probably a record mixing ratio too, yeah. Wow.
There's a 70 dew point in southwestern Iowa.
Yeah.
Oh, man. See, that might be, is that Waterloo or is that further to the east? Waterloo's further to the east. 70 over 70 on April
That one I think has always
27th.
been suspect.
What's that?
I feel like that VTAR has always been suspect.
Yeah.
Yeah.
But there's some 68s in southern.
Yeah, there's some 68s though. That's, I think, yeah, that's Lamoni.
How do you get that kind of a high dew point?
Yeah, there's no corn. I don't understand. That must be a little bit of an instrument error.
Spray bottle.
What's that?
Yeah, right.
Someone has a spray bottle.
Yeah.
About it.
I don't think the vegetation will be doing much.
I don't think so.
And look at these winds, 30 knots sustained.
Yeah.
Broad area.
Maybe with strong winds, you take whatever there is out of whatever vegetation there is, and you really can't. I don't know.
Desiccates it,
Yeah, it could be. I don't know.
Okay.
It's pretty amazing.
Well, have a wonderful weekend, thank you.
Yeah, thank you, Michael.
Oh, yeah, there's another hand, yes.
Oh, I was gonna say, if you Googled status of spring, you should see an animated map of the leaf out. Like you're talking about how the leaf out this year is like, you can see how many days it's late.
Oh,
Oh, yeah, that's really
what is that, Benji?
If you just Google status of spring, it's from the National Phenology Network.
Okay. So now they look at the leaf types.
Yeah, the first one there. And if you click on the first image there,
There's the date here.
Oh, okay. So blues will be late.
Blues are late, reds are early. Late, cold.
Oh, what a very cool map.
We should have this in shades of green, I think, and yellow.
Yeah, I know, I agree. Brown and green, yeah. So lots of places were early.
Boy, it's really stalled out right there.
Yeah, then it stops.
There's the front.
That is the critical latitude,
if you
man.
want to see a static image of what it is right now, you can exit this image, and if you scroll down a little bit, you can find it in that same, yeah. Scroll down and, or maybe, I don't know, it says it somewhere. Oh, download static map of spring leaf out, right? Yeah.
Wow, look at that. That's an awesome map. So it's already ahead of time in New England? It's coastal New England, but it's
Yeah.
we're 15 or 10 days behind. Yeah, that's so
Yeah.
cool.
That's
Well,
great.
thanks.
I really like
Maybe
that.
probably have
Thanks,
more
Benji.
But it's
list
ahead
of,
of time in central Illinois.
Yeah, right, way ahead of time. Upwards of 10 or 12 days. So there's a 1 month lag across the border.
Northern Florida.
Wow.
Be interesting to.
But they've already probably opened up, but they're just late when they
Yeah.
open, right?
And Florida looks nice in red, white, and blue, just like the Sandus wants it to look, so he's happy about that, regardless of what it means.
Right.
It'd be interesting to see if late frosts kill things. How does that like map on it? Can you see an ebb and flow and those?
Oh, yeah. We haven't really had a big cold air outbreak, but I wonder if you knew you had one, would you see it just kind of suddenly turn blue in some of those places, or just stop moving?
Oh, I feel like that's kind of with the tripole of colors you're seeing, like the flux of warming usually up and then it probably ebbs back down, not enough to kill
Maybe, yeah.
things in Illinois, but.
I wonder how much of this, though, is due to dryness.
Yeah, it could be a number of things. We know that's not it for us, because we've finally gotten a little wet, but
That moisture surge is coincident with that earlier than normal swath. You know, where the dew points are.
Right, that's right.
Well, that could, yeah, maybe there was some.
Yeah, maybe they're out already and they're
Right.
losing water today because it's so windy, or it's kind of interesting. It's a really interesting map. Status of spring, I gotta keep that in mind.
Well, thanks, John and Pete. And,
Yeah, thank you, Pete. And Benji, thanks for that.
Thanks for that.
They don't even, but look at Benji, they don't even talk